Okay, what I'm going to do is just start off with a one sample t-test, and what it should do is focus on how close to the same this is a problem we've already worked. Of course, there'll be a couple of differences, and we want to get those as well. So what we have here is a random sample of 49, so n is equal to 49. The sample mean is 31.7. With a sample standard deviation of 0.70. By the way, that's the big difference right here. This is how we know we're doing a t-test, because it has sample standard deviation. If you have sample standard deviation, you're doing a t-test or a t-interval. I'm going to go ahead and calculate then the standard error, but now it's SX bar because we have sample standard deviation. S divided by the square root of n is 0.7 divided by the square root of 49. And I believe that's going to be 0.1. Yes, 0.1. By the way, it says then, can we conclude that the population mean is less than 32? So we're going to reject HO if, now since we have sample standard deviation, it's t-test less than minus. It's the same rule as before. Look at your research hypothesis. So now what you need is a copy of the t-table. Now if you look at the top of the table, in this particular case, we have a 5% level of significance. So that's alpha is equal to 0.01. It's a one-tailed test. And then the degrees of freedom is going to equal to n minus 1. In this case, we have n is 49 minus 1, that's 48. So if you go first, I would recommend along the top of the table, one-tailed test 05. We see we're going to be in the first column there. And then just go down to degrees of freedom, and where it's 48 there, the cutoff is 1.677. So when you have a sample standard deviation, you have a t-test, correct for degrees of freedom. Then I'm going to compute the t-test, and that's going to equal to the statistic minus the hypothesized parameter over the standard error. 31.7 minus 32 over 0.1, that's minus 3, which is less than minus 1.677. So we reject HO and conclude that mu is less than 32. So anyway, you got your calculator out, hit your stat key, and go over to tests. Option 2 is the t-test. So for mu 0, that's from our hypothesis there, that's 32. For x bar, that's 31.7. I assume you're entering the numbers along with me here on your calculator. The standard deviation, remember this is the standard deviation, not the standard error, so it's the 0.7. And the sample size was 49. And then this last thing there, or the mu, last line before the calculate, all that needs to have the same sign as your research hypothesis. So make sure that says less than. And then hit calculate. And you will see there that the t is minus 3. And you will also see that the p-value is equal to 0.002. And that's the only way we will calculate the p-value when we have a t-distribution. To draw the sampling distribution of that, it's going to be really similar to what we had previously. HO was that we had 32 here. We actually found the sample mean of 31.7. And this area out here is the p-value, 0.002. The reason it's down here because we have a one-tailed lower. Remember, we're going to reject HO if the p-value is less than 0.05. Reject if p-value less than 0.05. 0.002 is less than 0.05, so you reject HO. Conclude that the population mean is less than 32. If we wanted to go further, and we do, we can go ahead and have the same interpretation of this p-value that we did. I'm looking at part D now, that we did on the previous exam. Same exact interpretation, or at least method. If mu is equal to 32, if the population min is equal to 32, then there is a 0.002, or very small chance, of observing a sample mean less than or equal to 31.7. By the way, we did get one of 31.7. Therefore, we're pretty sure that mu is not 32, because there's almost no chance that we would get this if the population mean were 32. If you haven't gotten the reasoning down on that yet, please go back and review and make sure you get that reasoning of the p-value ironed out. Okay, on part E, we're going to do the confidence interval. You know, if you sample repeatedly, what proportion of the intervals would include the real population mean. If we kept sampling, it's the proportion of intervals that would include the real population parameter, in this case the real population mean. X bar plus or minus t times Sx bar. Our X bar was 31.7. For 90% confident, we're going to still get that 1.677 times then the standard error, which was 0.1. 31.7 minus 1.677 times 0.1. That's 31.53 about. And then do the same thing, except for this time add. And I got 31.87. This is one of those intervals that we might have gotten, 95% of which would include the real population mean, 5% of which would not. But if we wanted to look at this interval and say, is it plausible that the mean could be 32, we would say no, the whole thing is less than 32, so we would be confident that the population mean is less than 32, again, because the whole interval is less than 32. We're also confident it's greater than 31. So the main conclusion is that the population mean, we're pretty confident the population mean is less than 32. The sample size is large enough, it's 49. It's large enough if there are no outliers in the population. Same rules as we used on the previous exam for the one sample Z test.